Hello everyone, welcome to the video. Today we are going to solve the problem Roman number to integer. In this problem, we are given a Roman number as an input and this number is given to us in the form of string and we have to return that what number does it represent in decimal form and we have to return that integer. This problem is an easy one, but the challenge lies in visualizing and making some observations that lead you to the algorithm. This problem also has some tricky edge cases that a candidate might miss. We are going to solve this problem today. We won't directly jump to solution, but gradually build and reach the solution. We discuss the questions of data structures and algorithms on this channel in simplest words with fundamental approach. If you are new to this channel, please subscribe. Let's start. To begin with, let us first note down the key things given in the question. So we are given a string. That string is in Roman numeral format and we have to return the integer corresponding to it. For example, if we are given this string, we know that this represents 5. So we will return 5. If we consider our solution as a black box, we are getting a string s as an input and we have to return an integer number as an output. So what will our function signature look like? Our function signature will look something like this. Before jumping to the algorithm, let us first try to understand the Roman number system. Let us first just try to get comfortable with it. So these are the symbols that are used to represent the Roman numbers. Let us start from our 1 and see how we will represent it. 1 is nothing but just a simple 1 line. Then 2, 2 lines. Then 3, 3 lines. Then 4. 4 is not represented as 4 lines, but it is represented as 1 and then a 5 symbol. So basically 5 minus 1 becomes 4. So we are reading this as combined and not 1 plus 5, 6. Similarly, 5 becomes this, 6 becomes simply this, 9 again is 1 and then 10. So it's like 10 minus 1, 9. Similarly, 14 and 15 and 19. So let's say, how do we write 44? Okay, so in case of 44, first we have to represent 40. So 40 is represented as XL, basically 50 minus 10, 40. Then 4 is represented as this. Similarly, let's try to write 49. Now 49, again 40 will be represented as this and 9 as this. Similarly, 135, so let's first represent 100. 100 is represented as this, 30, x, and then 5, 35. Now let's go for 399. So we represent first 300, C, that represents 300. Then 90. How do we represent 90? XC. Why is it 90? Because 100 minus 10 is 90. And then 9, right? So we can definitely make a few observations here, right? So first observation is that sometimes we have to read the string or the parts of string clubbed together and not individual character. For example, here we are reading C as an individual character for 100, but here we are not reading C directly as 100, but we are reading XC together and we are saying that this value is 100 minus 10, which is 90. So one thing is clear, that sometimes we will have to read parts of the string together. Second thing that we can see is that whenever we are reading parts of the string together, it is of size 2. For example, this XC or 1V or 1X or 1V here. And it is never more than 2. It is never a length of 3 or 4 that we are reading together. And thirdly, that whenever we are reading these two together, the second character always represents a greater number. That is why we can subtract the first number from second. For example, here we are subtracting 10 from 100. Here we are subtracting 1 from 5. Here we are subtracting 1 from 10 and so on. With these observations in mind, let us try to derive the algorithm now. So it is clear that we are going to iterate to read the string. So in every iteration, what will we have? We will have a current character and we can also have the next character, as we can see from our third observation that we may also need the next character. So what will we do with current character and next character? First of all, we'll check if the next character is greater than the first character. If it is, then like the case here, xc, then what do we have to do? We have to read the value combined. We don't have to read this as 10 and this as 100. We have to read this as combined, and we will say that this is 100 minus 10, 90. But if it is not, let's say if there is no greater character ahead to it, for example in this case or in this case, then we will just read it individually. And depending on how do we read it, our next pointer will move accordingly. If we are reading two characters together, our next pointer for the next iteration will move two places ahead. While if we are reading it individually, our next iteration will just move one place ahead. And with every iteration, we will keep on adding the number. And finally, when we are done at the end, we will return the number. Let us now see the code walkthrough for the same algorithm that we just discussed. You can also find the link to this code in the description. So first of all, we declare a map, which is from character to integer. What is the purpose of this map? This map will hold basically what symbol represents what number. So if you go to this function fill map, what are we doing here? We are simply putting the character and number mapping here. So once we have filled this map, we declare some variables. One of the variable is number that we will form gradually and return finally. Then one of the other variable is an iterator that we will use to iterate over the string. We also declare a current character and a next character. So first of all, we first take care of an edge case. That edge case is that if the string's length is just 1, there is one character, then we have to simply get that value from the map and return it. Now we will iterate. We are using while loop to iterate and not for loop. Why? Because we don't know whether in every iteration we will move two places or we will move one place. And for loop is useful only when we know that our iterator will move by what fixed positions in every iteration. So here we are using while loop, and note that we are only moving till second last character and not further than that. Why? Because in every iteration we are also calculating next character. So when we are at second last character, we will be able to get the next character here. So first of all, in the iteration we get the current character and the next character. Then we compare these values, and if the next character is greater, we know that we have to read this part of the string together. So we calculate the value, numerical value, by subtracting the previous character's value, by subtracting the current character's value from the next character, and we add that to the ongoing number. We move our pointer two places ahead. And if it is not greater, then we simply get the value of current character and add that to the number. We move our pointer one position ahead. Then it is still possible that our last character was not covered in the loop. Why? Because if the I was not moved to two places but moved by only one place, then that means our last character is not covered. So we have to take its individual's value. So for the last character, this is also an edge case, we need to take care of it. So for the last character, we get the character and we get the value from the map, and we add that to the number, and then we return the number. Let us quickly summarize what all we did. First of all, we just understood the problem with the help of an example. Then we visualized it, we made some observations, we got comfortable with the Roman number system. We could see that while reading the Roman number, there were some situations where we had to read the parts of a string clubbed together. And that part was not more than length 2. And in that part, next character was always greater than the current character. With the use of these observations, we wrote the algorithm and we did a code walkthrough. The link to this code is in the description. This is it for this video. We will meet again in the next video with some other problem. Thanks for watching.